So there's a recording in progress, so I can go now. Can I advance the slides, or do I got to ask you, Cameron?
I will advance them for you. Do you want to say much more on this title slide?
No, it's just a nice picture. It's the picture of the plot, the first year plot. So thank you to Practical Farmers of Iowa and everybody for inviting us to give the opportunity to talk. It's been this whole on-farm research thing has been an incredible learning opportunity for me, and I'm glad to share it with you. If I'm talking about what I do on my farm, I always like to start off with this slide here, and the lower red dot just outside of Detroit is where my farm is. This just gives everybody an idea of my location, where I am in respect to where maybe you farm, and just to acknowledge that what I do may not translate 100% to your farm, and to just keep that in mind, that just pick up ideas, but just be aware that it may not all work the same. So I'm, as you can see, down about an hour's drive from Detroit. It's old lake bed, alluvial clay underneath, very poorly drained. So everything is systematically tiled. Soil or topsoil varies from sandy loam to clay loam, sometimes within 100 feet of each other. It's fairly productive. We have an interesting situation in that we're between these great big lakes that tends to moderate our particularly my winter, our springs, and our falls. It's a very humid summer by nature usually. And so on my farm, I grow corn, soybeans, winter wheat, sugar beets, which actually go to Michigan sugar, sunflowers, which I just introduced, and used to grow processing tomatoes for the H.J. Heinz company until they closed their door about 7 years ago. I'm also have a hog finishing barn on the farm.
And I'm the other red dot that's on there. I'm the crazy grad student who got hooked up with Woody. We'll talk about that story in just a little bit, but I'm in Guelph right now, and graduated from the University of Guelph, did a master's of science there a couple of years back, and got to work with Woody for that project.
Well, I always like to talk about how I got into all this, the soil health and cover crops and things like that. And it all started with a little bit of a light bulb moment. And I hate to think that it's almost or over 40 years ago now, plowing for my dad and plowing up old corn stalks from the previous year. And some of that was due that it was just a crappy plow, but I was lucky that my dad and I looked at that field, and he was open enough to realize that we needed to change. And shortly after that, the plow left the farm, and we had switched to a chisel plow type system. We also started to reduce tillage passes. We eliminated fall tillage passes on our soybean fields that fall, things like that. About 25 years ago, I started to at that point to no-till soybeans and wheat. Still doing tillage for corn, and started to introduce some rudimentary cover crops, mainly to reduce wind erosion on sand hills or sand knolls. Sugar beets were introduced to the farm about 25 years ago, and that was the inspiration for the strip till portion of the farm. My standard practice was to do all my tillage in the fall, primary and secondary, and then stale seed bed the sugar beets in the spring, which left the ground vulnerable to wind and water erosion all winter. That sparked a thought of strip tills, which would have, my thought being, leave a lot more residue on the surface, only working 25% of the soil where I'm going to plant my sugar beets. And that was introduced 13 years ago on a trial basis. The following year, everything, corn and sugar beets, were changed over to a strip till system. I have since dabbled in no-till sugar beets and a little bit of no-till corn as well. So it's still very much a progression. So this 40 years, or particularly the last 25 years, I've kind of started to think about how I wanted to work with my farm. And I developed these goals to help me make decisions when I change, particularly tillage or cropping practices on the farm. And the first one is to do as little tillage as possible. I'm still at strip till, so it is a little bit of tillage, but I'm slowly reducing that. Keep the soil covered as much as possible, whether that's a cover crop or crop residue, and to keep a living root system growing 365 days a year, whether it's a crop or cover crop. And all of this has to kind of fit into an economic model that works. I could save my soil and go broke doing it, so I can't. It still has to make economic sense. And just the fact that I grow sugar beets is one of the reasons I still have to do a little bit of tillage. But right now I'm down to a strip till pass and a pass to incorporate a cover crop and level the field for planting into the spring. So I'm down to two less invasive tillage passes for sugar beet production. The other thing that I've done is, one of the first things I realized, I guess, with strip till is I had an opportunity to plant cover crops between the strips because they weren't going to interfere with my cropping practices. So shortly after that, I introduced the cover crop strip till combination, I call it, and I've done that both ahead of corn and ahead of sugar beets. And I really like how it works. It gives you the flexibility to use a cover crop without it interfering in the spring with your planting, and gives you a larger window for cover crop control. So as I mentioned at the beginning, I have livestock, so I have manure, and I like to bring my manure to the field in the summer after winter wheat. Usually soil conditions are much better, drier, everything carries a little better, and I have a lot more time to do it. I've been in the pig business for as long as I've been on the farm, and being a mile south of Dresden, applying manure on a hot, humid day in July usually didn't make me any friends in town. So I started to inject the manure, partially to eliminate the smell, but secondly, to try to keep the ammonium gases from venting off and keeping things in the soil, try to keep the fertility in the farm. Unfortunately, that was a big shank injector. It required one or two tillage passes again to level it after the manure was applied. So I decided I wanted something better and came up with what I call my shallow injectors, which is Flexicoil single disc seed openers with everything stripped off except the discs. They tend to cut a 2 to 4 inch slot in the ground, and I dribble my manure there. It doesn't all get it below ground. It's not blown in the air. It's applied almost at the surface, and it has an opportunity to get into the ground. This has worked well. And the other thing it allows me to do is a day or two later is just follow that with a drill, plant my cover crop. Don't have to worry about another tillage pass. It's level enough to plant. And then I like to band spray that cover crop, and like in the next picture next to it there, and strip till that, and that'll usually go into a corn crop the following spring, as in the bottom corner there. This is what kind of led me to my question is, how much fertility am I saving by using this cover crop system, and how much can I rely on that to grow my next crop of corn? So this a couple of years later, and I was on a committee with our provincial government on a soil health strategy working group, and I met Dr. Ralph Martin, who was on the committee, and after a couple of lunches and breaks and chats, we kind of come up with this plot idea. And he says, I've got just the guy that can do the work. So we sat down and developed our plot to apply manure, plant cover crops, and see what we could do in the following year. So Cameron got involved really quickly. We also had Travis, who is a soil microbiologist. And the interesting thing about this plot is they are 20 by or 40 by 90 feet, 90. I believe. Yeah. 90, yeah, 100 less than laneways.
Right.
Allows for a lot of people to poke around without stepping on each other's toes. So that turned into our 2-year project that Cameron still twitches about every once in a while, I think, when he thinks about it.
One of those recurring nightmares that you have.
Yeah. So that's how the project came about and evolved. And now I'll let Cameron talk about all the work he did as I sat back and watched him.
Oh, Woody, you were hardly sitting back and watching. You were actively involved and felt my pain. No, the joking about it being a nightmare is only partially true. This was an amazing project and an amazing opportunity. It's part of the reason why we're here talking about it today, is because we learned a lot of really cool things, both from the project itself, but also from the opportunity to collaborate. So as Woody said, because these plots were large, it gave a lot of opportunity for different people to poke around. And I ended up having to poke around in 2 slightly different ways. So as Woody mentioned, this project originated with the idea of how much value does he get from the fertility of his manure going down with a cover crop, and how well does that carry over to the next season. So that's kind of a nitrogen side of the of this experiment that we were looking at. But then there was also what became my master's thesis, which was looking at the impact of cover crops on water, and I ended up calling them service crops. Published a paper on that, just kind of making the case that we grow them for more reasons than just covering the soil. We grow them for the ecosystem services they provide, or a variety of other things that improve water supply to crops rather than just keeping the soil covered. I'm not going to really get into the water side of things in our talk tonight, but just to make you aware that there's a whole nother side of this project beyond just the nutrient management side. And then, as Woody mentioned, there's Travis, who is looking at the microbiology side of things. So there's a lot of different angles to this, which were really fun.
And just for a little bit of background context, how much annual rainfall is on the Van Arkel farm?
35 inches for our area. That's winter and summer.
Yeah.
Great, thanks.
Yeah, we'll get to some weather slides later, though I warn you, it's going to be in centimeters. All right, so yeah, the manure side, the way this experiment was set up, it was replicated. So we had 4 replications. Each replication was split, looking at manure and no manure. And then within that split, we had 4 cover crop treatments, a control, no cover crop, a single species, a 4 species, a 12 species. We'll get to that in a sec. And then the following season, there was a side dress application at around 6 to 8 leaf stage in the corn crop. So some of the data that we're going to share now is in a paper that we're trying to publish and hopefully under review and hopefully successful. So yeah, really this question, can cover crops carry over manure nitrogen to the following corn crop? It's been researched somewhat before. The idea that cover crops can catch nitrogen, maybe you've heard of them called catch crops. This is very well researched, lots of data behind this. Cover crops can take up nitrogen from manure, nitrogen that's left over in the soil that could be lost. But the question is, can they release that nitrogen the following season to the corn crop? And the research on this is a lot less clear. Nitrogen release from cover crops is going to depend on the species that are there. Different species are going to produce different amounts of biomass, and that biomass is going to have different carbon to nitrogen ratios, and that's going to change the way that it breaks down and whether or not nitrogen is released or whether or not it's being immobilized as microbes break that down. Legumes, really clear. Like Ontario, we've got lots of data. Red clover, nitrogen release syncs up really, really well with corn. That's not necessarily manure. That's just nitrogen release from the cover crop. Grasses, do they do that? And that's not clear. So this is kind of the question that we were looking to get at here. And so we'll just share a little bit about how this experiment looked. We had 2 sites, as Woody mentioned, on neighboring fields. Woody kind of talked about the soil texture at his place. It's heavier soils. It's a Tavistock maple wood if you're a soil classification nerd. I think that's all I need to say here. Here are those cover crop treatments that we were working with. So again, a control, cereal rye as our single species, and then added a crimson clover, Japanese millet, and sunflower for our 4 species. And then we took those 4 species, changed the seeding rates on them a little bit, and then added 8 more. And that became our crazy multi-species mix.
And if anybody's interested, kilograms per hectare translates almost to pounds per acre.
Pretty well, yep.
It's pretty close translation.
Yeah. Woody, you were putting down 8 gallons per acre, is that right? No, 8,000.
Yeah. My target was 7, but I think I ran high. Yeah.
Around that. Yeah. Okay. And then the following season, again, kilograms per hectare, but that was probably 160 pounds per acre, the side dress UAN.
Yep. Target was 160 pounds per acre.
Pounds per acre. Yeah. Okay. And here's a little bit of a timeline of how that worked. So right after winter wheat harvest, Woody, you went through and you injected that manure. You got the cover crops on pretty soon after that. And then you're strip tilling in the fall, but not freshening up in the spring.
That's a stale seed bed in the spring. Yeah.
Right. So then you can see some of those S1 through S4 is the times that we were sampling the cover crops. So we collected biomass in the fall. We'll show some of that data. Not going to show you biomass or residue that's left over in the spring or later on in the season, but then terminated the cover crop about a week before corn planting. And that'll become important as we kind of get to the results later on. And then, as we mentioned, side dress and carry that through to corn harvest. That DR/IR is just related to the water experiment, but we don't really cover that today, but we kind of imposed a drought treatment and an irrigated treatment that we looked at as well. So I love this picture just because you can already see the the different textures in the canopy because of the different treatments we had. So we got some good results. This was our cover crop growth in the fall of year 1. So we tried to take cover crop growth kind of around the time of that first killing frost, later in the season. And so in year 1, you can see particularly, this is going to be the important detail, is that in that manured treatment, adding the manure really changed the composition of the species that were in that mix. And Woody, maybe you want to talk about that a little bit more, the things that you saw.
And that's year 1. So we had a warm, long, damp late summer and early fall. So some of the dominant species in the 4 and 12 species mixes were very aggressive and out competed things like cereal rye and some of the other things. I think A is the total biomass, or sorry, red. The red bar is total biomass.
Right. Yeah. So the solid colored bars are the total biomass. Here, maybe you can see my cursor this way.
Yeah.
So these would be the total amount of biomass, and then this is the amount of cereal rye biomass that's within those mixes. But obviously, it's going to be the same for rye. But just kind of showing that as you got into these 4 species and 12 species, and then as you added manure, the proportion of rye in that species, how it grew out, changed, which looked different in year 1 than it did in year 2.
Year 2 being a bit drier and a bit cooler, or
right,
at least cooler anyway, yeah.
And I guess the main point just to say here is that in year 2, even with that manure there, rye really dominated those cover crop mixes. And here's kind of a comparison of how that looked. So you've got year 1 on the left, year 2 on the right. They're taken within a day of, same time in the year, but just very different growth. And well, Woody, you can talk about how this was to manage.
Well, year 2 was easy. Year 1 was a challenge because the dominant species happened to be sorghum Sudan grass, which was as tall as the cab of the tractor I used to strip till. So there was an extreme amount of high C to N ratio biomass that following spring.
Right.
And being that tall, I could not do my standard strip band spraying practice. Neither. It was purely strip till, so no band spraying, which didn't give me as clean a strip as I would have liked to have seen.
Sure. And
that was the picture of me strip tilling through 12-foot tall sorghum.
Right. Yeah. Pretty hairy. And this is just to kind of illustrate what Woody was talking about there with the moisture conditions. The white bars are the rainfall for that month. And so you can see we just had a ton of rainfall in July and August compared to the average in that first year. We had nice warm temperatures, and year 2 was, average or maybe even a little bit low. So interesting just how weather is going to change how that cover crop mix shows up. But I guess that's kind of the reason that Woody, you and Ralph picked the species that you did.
Well, the species, it was in the question. The species were all in the 4-way mix we tried for warm and cool season broadleaf and grasses, and then tried to sort of keep that balance close in the 12-way as well.
Right. Okay, so we're going to jump through a whole lot of the season. We're going through the winter, we're going through the corn growing season, and we're just going to cut straight to the final yield. So this is year 1 again. Keep in mind the the trends that you saw in the proportion of cereal rye in that cover crop mix. Okay, so in year one, when no manure was applied, there was no difference in corn yields. When manure was applied with the cover crop, we saw a significant reduction in corn yield following cereal rye compared to no cover crop or compared to that 12 species mix. There's enough variability that you can't really say that there's a statistical difference between corn following rye and corn following that 4 species. But definitely you can say that compared to corn following the 12 species or corn following no cover crop, corn following rye did worse. And I think the other point to kind of make here is just the size of that yield loss. Like I think it's about a 15% yield loss, really, really nasty. Year two, same kind of thing in the no manure, where no manure was applied, there were no differences in corn yield after those cover crops. But when manure was applied, we started to see reductions again in yield. So we definitely saw a reduction in corn yield following rye compared to no cover crop. But then we also started to see some reductions in that 4 species and that 12 species again, so that they weren't different in their yields with corn following rye. Maybe you could say they're a little bit of an intermediate. And so we're seeing some kind of reduction there. But keep in mind that this matches up quite well with the proportion of rye that was in those mixes in year two. In year one, when we put manure down, those other species, because of the growing season, they could take off and rye really wasn't able to compete as much. Year two, different growing conditions, rye took up more of that mix, and it seemed to have shaken out in the final corn yield. Which kind of brings us to these questions of, okay, well, what's the issue with corn following rye? And why is manure making the problem worse? Like maybe it's just a matter of you're putting the manure down, and so you're getting more growth out of it. I think it's probably as simple as that. But maybe before we kind of jump into some of these questions about what are the issues with corn following rye, Woody, maybe you want to talk a little bit about some of your experience with planting corn after rye, and that what we found through this experiment wasn't necessarily something that you had seen before. Is that right?
I shouldn't say I hadn't seen that. I hadn't realized it, partially because I've never done this thorough a side-by-side. And the other thing is, because of that first year, we had such a massive growth in cover crop that I couldn't band spray out my 12 inches that I normally do before I strip till, that the cereal rye was actually growing closer to the corn, or there were dead cereal rye plants closer to where the corn was coming up than I typically like to see. So I'm not sure. I have since really leaned back on using cereal rye ahead of corn until I figure this out.
Fair enough. Okay, so
Woody, there's a question in the chat box too. What was it like to plant corn into the residue left over by the 12 species mix?
The strip till actually did a pretty decent job of giving me a clean strip. That's the one reason I left it standing, is I didn't want to have it rolled flat or mowed flat and have it all different directions. It was kind of like pulling a comb through hair, and everything leaned, fell the right way and moved over. So that worked out better than I thought it was gonna. It was still a little hard on my nerves, and I don't think I want to do that again, really. But it did work out fairly well. And that 12 or 10 foot tall cereal rye and 6-foot tall millet that was in that pretty well wiped out the rye in some places due to shading.
Mm,
So
yep.
there was very little spring growth after in year one. There was some, but not a lot.
Yep, exactly. So problems with corn after rye, maybe you're familiar with some of these already, but if you talk with farmers and if you dig into the literature, these are the things that you usually come up with. One of them is water. So the rye cover crop in the spring starts taking up moisture as it grows, and depending on the time that you decide to terminate that cover crop, it may have already taken up moisture, which then the following corn crop needs to use. So maybe it's a water issue. Now, as I said, I didn't get into the water side of the experiment, but my whole master's thesis showed that water wasn't an issue here. There wasn't water that was being taken up by those cover crops that the following corn crop was not able to use. There were no differences that we could pull out in the amount of water available in those treatments. So really, the second one there is nitrogen, and the idea that cereal rye, being a grass, tends to have a higher seed-N ratio than legumes, and so maybe it's contributing to some nitrogen immobilization in the soil. So this was some of the data that we collected from this experiment. We looked at the amount of nitrogen that was in the corn plant as it was going throughout the season, and then the amount of nitrogen that was in the grain. And the trend was pretty similar. We saw that there was, yes, less nitrogen in the corn grain following cereal rye compared to these other cover crops. But you have to dig a little bit deeper than that, because is this an issue of nitrogen supply in the soil? Or is this an issue of nitrogen uptake? Or what is the issue here? And so there were no differences in soil nitrogen levels. So that's the first thing, is the amount of nitrogen that was available in the soil was not different between these cover crop treatments. So it at least didn't look like the rye had taken up nitrogen that was then not available for the following corn crop. There was also no impact of cereal rye on the C to N ratio, the carbon to nitrogen ratio of the corn biomass or the grain, which is to say that the reason that we see this reduction in corn grain nitrogen is just because there's less grain, not because the nitrogen content or the C to N ratio of it has changed. So because there's less yield, therefore there was less nitrogen taken up into the grain. But that's more of a reflection of the total yield than it is whether or not that nitrogen was being effectively taken up by the corn crop. So what is the issue? If it's maybe not water and it's maybe not nitrogen, then we kind of get to this allelopathy idea, which we know if you've been playing around with cereal rye and glyphosate-resistant Candida fleabane, we see that allelopathic effect really clear. But other research on allelopathy with cereal rye says it's likely not an issue for corn. And here's just a few studies here that kind of talk about that, but I'll let you go into greater detail on those if you're interested. So then really there's this last one, which is disease. And this is I think a couple of interesting studies that found depending on the termination time of that rye cover crop prior to corn, changed whether or not you saw differences in corn yield or corn population reductions and corn yield per plant. And so the idea is if you're terminating more than 10 days prior to planting, that then you're killing the cover crop off, and those roots and the above ground material is dying off. And if there's Pythium species on those roots that are also pathogenic on corn, then you're giving enough time for that cover crop to die off that you're not going to see those same issues kind of bridge over into your corn crop. And so that's what these folks found, is that rye before corn, when it was terminated less than 10 days, reduced corn populations, reduced yield, and reduced yield per plant. And as we mentioned at the beginning, we terminated our rye cover crop, all our cover crops, about a week before corn planting. And so this is just to show that in year one, we didn't see any change in corn population following those cover crops compared to no cover crop. But in year two, we saw a clear reduction in harvest populations compared to no cover crop. The reason why we think we didn't see that in year one is because we had a very wet spring after planting, and we had a bunch of cold temperatures. And so we just had low populations across the board, and Woody and Ralph and I were walking through the plots and trying to figure out what we could do with that year, because we had bad establishment, and it didn't seem like it was associated with any of those cover crop treatments necessarily. It was kind of across the board. So Woody, what did we learn?
Well, we learned, and I'm sure you'll agree, that we probably were a little too complex. We probably should have simplified it. There was 64 replications in there.
Like 64 plots or something like that.
Yeah, 64 different plots. The variability from year to year with the multi-species added some challenges to getting, I guess what you call, data, consistent data. You talked about the negative effect of cereal rye. I think we figured out that nitrogen carryover from manure is probably difficult to predict, considering weather conditions, winter, things like that. We did create probably way more questions than we even come close to answering. So, and wildlife played havoc with the first wildlife was the foxes that went out and chewed off all the little flags and sticks, pulled up sticks and flags and pulled them all over the plot. You had field mice chew through sensors.
Yep. They like nesting in those boxes.
You even stumbled on a skunk once, didn't you?
I think Catherine did. I think your wife
or
did.
Is it, oh, my wife. Yeah, somebody stumbled onto a fox or a skunk.
Skunk. So. She was pulling up one of the troughs that we were using for the drought experiment. Yeah. So definitely some excitement.
It was a great insight for a farmer on the complexities of valid research. I have a greater understanding of it now. Research from a farming point of view isn't just putting a strip down the field and calling that a plot. It may be an indicator of something, but it's not a measurable outcome.
And I'm sure Maggie's going to interrogate us on that a little bit more, but just to say, we gotta give a huge thank you to a whole bunch of people who were part of this project. From me, particularly a huge thank you to Woody, Catherine, their family, for all their help. Catherine was such a trooper. She helped out so much throughout this project. My advisory committee that is there: Ralph Martin, Bill Dean, Laura Vanier, Sheen Biswas, and then a whole bunch of other folks and funders. So this was really good. And Woody, I'm thinking we maybe got a little bit of time that we could throw in this fun little experiment that we did.
Side experiment.
Well, yeah, the side experiment.
So I get a phone call from Dr. Ralph Martin. He says, "Do you own a skid steer?" And I give him a perplexed no, and it dawned on me, he wants to drive a loader through the plots. And so I asked why, and he wanted to conduct measurements and different treatments on how much force it would take to pull a root out of the ground. So a farmer engineered over-engineered a tripod that had a little ATV winch and load cell, and you had a monitoring device, and used a cable puller and a screwdriver to attach it to the winch, and you were pulling roots out of the ground, corn roots.
And most importantly, Catherine and I were hauling this thing through the field.
Year 2, I put a set of wheels on it and a battery carrier and handles to make their life a little easier.
Right. So just warning you that this is what you might get roped into. Now, we did find some interesting results from this as well. So just in case anybody is thinking that maybe this is just totally a pipe dream, there is some research on this. It's more in the case of corn genetics, and that research is really just comparing different corn hybrids and root strength when folks were looking at lodging differences. So we're in a bit of a different system here, but Ralph is like Woody, is a really out of the box thinker, and thought, well, why don't we try it in this experiment? And so we saw some differences here, which is really interesting. Corn plants, and particularly in those following those multi-species mixes, were harder to pull out of the ground than corn following that no cover crop. And the reason why we did this initially was because we thought, well, if cover crops are going to, their roots are going to grow down through the soil, create pores that then, as those roots die, the following corn crop can use those same pores to access deeper soil water. There is some research that shows that cover crops can accomplish this. And so we thought, well, if those corn crop roots are going deeper into the soil, maybe we can pick it up by this. And so initially we thought, hey, maybe this is what's happening here. But this doesn't necessarily translate into yield. In fact, the yield trends, which we already showed you, are more reflective, and so kind of don't match with this, which is why this at least is my standing theory, is you've got all of these cover crop roots that are going through the soil, holding those soil aggregates together, making it that much harder to pull a root ball out of the ground. And which becomes an interesting thing to think about as we talk about the value of cover crops for stabilizing the soil, preventing soil erosion, and this kind of being an interesting and a novel way to measure that. So a fun little side experiment, which involved some backbreaking work and some creative thinking, but valuable.
Oddly enough, nobody wanted to take that monstrosity home and do further work with it.
It's been repurposed, recycled.
It's been repurposed, yeah.
So where is it now, Woody?
It was used, actually, I think it was used for some modifications to a band sprayer for cover crops. So it's gone to a good home.
Right.
Well, it sounds like the two of you have had a lot of fun, even with the headaches that went along with it. You had fun in this on-farm research journey. Woody, had you done any on-farm like trials before this experience, just on your own or with anyone else?
I have right now on my own. I had done 3 replications of some different nitrogen rates and things like that. I've done some strips in fields, which I thought was research, but is an indicator now that I know. And actually right now I'm involved with Agri-Food or Agriculture and Agri-Food Canada on their Living Labs program, which is on-farm in-field research. So I'm still at it.
Great. And then Cameron, was this your first time working with like an actual farm rather than working on a research plot someplace or something along those lines?
Yes, exactly. Exactly. Yeah, I had worked throughout my undergrad at the Aurora Research Station, which, if anybody knows of Ontario research, there's kind of there's a couple of long-term research stations, and one of them is Aurora, and so I worked on a couple of experiments there throughout my undergrad, which were very valuable and taught me a lot of transferable things to understand woody system a little bit more. But yeah, this is my first time collaborating with a farmer on an experiment.
Do you have any plans for any upcoming on-farm research with anyone else or continuing on with Woody?
I am not in a research role anymore. I after my master's, I moved on to work for an initiative called Soils at Guelph, which was kind of mobilizing University of Guelph soil science, connecting with farmers. And actually just recently, earlier this year, I'm now working for the Soil Health Institute as a soil health educator in Canada. So I'm not in a research role anymore. Now I'm more in an education type role around soil health management.
So I am going to ask Cameron and Woody a couple more on-farm research questions, and I encourage everyone to put any questions into the chat as you're thinking of them, but particularly anything related to this experience of doing on-farm research. And in about like 10 minutes or so, we'll just open up the rest of our time together for all of your questions. I'm curious what the two of you, how you would answer this. What are the key ingredients to making farmer researcher partnerships work well?
If your research or lives more than 2 hours away, or be prepared to have your couch, your refrigerator, your stove and bathroom invaded at the end of a long research day. There was lots of times I walked in the house and it looked like a youth hostel sitting around my kitchen table, which was fine. It was made for interesting conversations.
And I'd add that from someone who didn't grow up on a farm, my grandfather was a dairy farmer, and so I was never far from the farm, but didn't grow up on a farm. Being able to be part of that youth hostel at the Van Arkel's place was invaluable for me in being able to understand Woody's farm, Woody's operation, to just enjoy being with their family, but related to the research, to really get some practical boots on the ground experience with what Woody was doing. So that was, yes. While the 2.5-hour drive was not ideal, it provided some intentional time.
And I think it's important to have the farmer research have a common goal or common philosophy, if you will, maybe, so that you're not trying to accomplish two different things out of your research.
Well, and then the other thing to consider is that it wasn't just the two of you for this project. There were actually at least 2 other people involved. So how did you stay on the same page with all parties in that way to make sure that everyone's goals were kind of aligned?
I've heard a person once say, "Blessed are the flexible, for they shall not be bent out of shape." And so really you need a strong coordinator. You need to identify someone who's going to coordinate things. And just because my role in the project was a little bit central, I then ended up doing a lot of coordination with Woody. So I was the one who was texting Woody going, "Are you spraying tomorrow? Are you spraying tomorrow? Are you spraying the next day?" And we're really just trying to stay on top of things. And then when we knew that we were ready to go, I'd be calling the team and we'd be coming down. So really valuable to have kind of one person to be able to coordinate with the whole team, and especially when you've got lots of people with their hands in the cookie jar.
And the plots were large enough that you had room to do sampling without interfering.
Right.
And there's a lot of value there in that. I took the time and energy to put the plot in. The more people that can, pull some data out of that was, I just see the value in that. I even had some of our provincial extension staff, weed specialists stop in just to see if he could identify different weed issues in the different plots. So it was open to a lot of people.
Mhm.
Has your network expanded, Woody, since this project? Like just realizing what other resources as far as people with certain expertise have and people you can reach out to?
I Well, I was like Laura's, or I was going to say Cameron's supervisors. I was well acquainted with 3 of the 4 already, but I did get a chance to interact with some soil microbiologists and things like that. So that was interesting. That was a conversation I'd never had.
So if the two of you could redesign this project and do it over, or maybe change your question around a little bit, like what would it look like if
It
you had
would
the
be
opportunity to do that?
an hour, 2 hours closer to Guelph, is what Cameron would say. I think simplifying it. I don't know if
Mhm.
at least eliminating the 4 and 12 and maybe 1 and 6, so 0, 1 and 6. I'm not sure if the nitrogen side dressing portion could be pulled out.
Yeah, well, it becomes a question of yeah, how do you design the experiment? And we've got a long history of like reductionistic research designs, meaning that we try to control for every variable so that we can then attribute different results to a specific variable. And so that's why this experiment got so hairy, is we wanted to be able to say, well, this is the effect of the manure, and this is the effect of the cover crop, and this is the effect of the side dress application. And we wanted to be able to separate those things out. Whereas, like Woody, those aren't the decisions that you make as a farmer. If you're going to make a shift, you're going to make a system shift, and you're going to tweak a whole bunch of things in the process. And so I think Woody's right in, I think there's a lot of value if you're trying to address both questions that farmers have and get some research, like bring the value of research to it. It's simplifying it to address changes in systems, and maybe not so much trying to isolate out all of those individual impacts, which maybe is better at a research farm where you can control the variables a bit better.
Well, I would add to that, Cameron, that brings research to the farm and looking at systems, and it gives them a better idea of what they can do. They can nitpick little things out and take back to the research farm and do that
right
reductionist research. So it's kind of like an indicator of what needs to be researched,
right.
Maybe not necessarily a defined answer.
Right.
It's bringing people out of their silos, including myself. It brought me into a new world that I was really not acquainted with. World of research.
Well, before we open things up to the other questions, which there's a lot in the chat, so I definitely want to pivot and start answering that stuff too. Like, is there one significant takeaway or call to action or like anything that you would want to comment on your experience doing on-farm research before we transition and talk about a bunch of other details?
I'm going to just repeat my last comment, is that if it's not, you don't get the results you want from this research, but what it does is it brings farmers and university research out of their silos and talking and communicating. And I think it just makes for more knowledge on my part, but secondly, it gives research exposure to what actually happens on a farm.
Mm-hmm. Yeah, I'd echo that. And to maybe say it in a slightly different way, I think this kind of participatory research, I think really, really highlights the fact that we all have different expertise. Expertise doesn't just come with a couple letters beside your name. It comes in a variety of ways. And so the value of these sorts of opportunities is myself as a scientist, as a researcher, I'm better able to understand the questions that I should be asking about cover crop research because of Woody's expertise and because I'm being exposed to his expertise. And so it's just a really good thing to, I think that's one of the great things of participatory research is you get exposed to a variety of expertise, which is really important.
Really exciting because you don't know what you'll uncover in that process.
Right.
All right, well, let's apply the variable expertise to some of these questions. Let's see. There was one back in the beginning about somebody wanted to know, Woody, how do you keep your manure from burning your cover crops?
So the manure is applied before I seed cover crops. So I usually, it depends on the weather, but I usually let it dry off, and then I just seed into it. And I've very seldom, where applications are even, I very seldom have an issue with burning cover crops or cover crop seed.
And Cameron, in order to best synchronize nitrogen release from clover to corn, when and what is generally considered the best method to terminate the clover?
Woody, you're going to need to keep me straight here, but I'm pretty sure that most common method is spraying it off in the fall, and usually people are incorporating it as well.
Yeah, there's not a lot of difference whether it's tilled under or left. Usually there's some kind of tillage so that the residue matting isn't an issue in wheat in the spring. I do with red clover when I use it, I do the same thing as I do in that picture. I band spray and strip till and terminate the balance, the 20 inches in between the rows at around planting. I don't think that really creates more, and I don't think it has enough time in the spring to ramp up nitrogen production, but it's keeping that living root system is my goal. But as a rule in Ontario, frost seeded red clover after winter wheat is terminated probably October, 1st of November-ish.
Yeah, and just to be clear too, like that synchronizing nitrogen with corn, we see that with red clover. We don't necessarily see it to the same degree with other clovers, crimson, white, any of the other clovers you look at. So it's a unique thing for some reason with red clover that it really syncs up well with when the corn crop needs it.
And there was a follow-up question on that too, about if you've seen anything in the literature on how end release and timing of termination should differ when clover termination is by tillage or chemically and clover left on the soil surface. Do you know of any studies or anything that?
I'm not aware of anything chemical versus tillage and how that affects release.
I just know that the later you can terminate into the fall, the more nitrogen production you're going to get.
Right. So more a timing issue than a termination method issue.
And most I would suspect is chemically terminated at this point.
Yeah.
And then another question for you, Cameron. Are you familiar with Cornell's work or model that predicts nitrogen release from covers based on C to N ratios?
I've heard of it, yeah, and I'm not super familiar with it, but but certainly it's an interesting thing. It's so dependent on timing, right? Because technically this is the thing with, even when we were terminating our cover crops, Woody, you're planting like pretty close to the 1st of May. And so we're terminating late April. The C to N ratio of all of the cover crops at that time is really low. Like they're not at levels that you would normally say nitrogen immobilization is going to occur. So
especially
yeah.
the second year, Cameron. The first year, I think it may have
Yeah.
been an issue with that tall. We had a lot of
right.
sorghum Sudan residue,
Yeah.
which is higher C to N, and a cold backward springs as well. So
Right. And that was the year where we didn't necessarily see yield loss on those treatments, despite the fact that we had all of that really tough fibrous cover crop residue on the surface.
What value do you feel sunflowers specifically bring to the service crop outcome?
service crop, Cameron, your influence is.
I've won someone over.
Actually, I grow sunflowers now, so I've pulled them out of my mixes. But it's just a plant it's a warm, I call a warm season broadleaf, and it's not related to, at the time, anything I was growing on the farm. I like sunflower root systems, and residue tends not to be an issue. So it's one of my favorite.
What's special about their root systems?
I have chased the taproot down 18 inches, the size of a pencil, and the top is this nice fibrous. It's a great scavenger, pollinator habitat, because if I plant the 1st of August, by the 1st of October, there's usually flowers, so late season pollinator habitat. Yeah, it's one of my favorite species to put in a blend, even a simple blend.
So you're just growing sunflowers as what are you doing with your sunflowers now?
They go to a little processor down the road that cold presses premium sunflower oil.
Okay. And Woody, what cover crop are you now using between wheat and corn, and what is the goal or goals for that cover crop?
It depends on whether I'm applying manure or not. If I'm applying manure, I was multi-species, and I've been slowly tuning that back. It tends to be an oats and something combination. Oats and maybe a little bit of volunteer wheat, oats and crimson clover. It varies, depends on what's in the shed for seed. If I'm not applying manure, it's frost-seeded red clover, terminated, half terminated in the fall, half terminated in winter, spring.
And then when do you seed that clover?
So it's frost-seeded in March, on a frozen morning, usually with a four-wheeler and a small seeder, and we'll spread that. And
what are you at? Are you 10 pounds per acre?
I'm running 12. I'll pay for a couple extra pounds.
Yeah. That's another little sidebar. Is we did another little project I did was some survey research on red clover success, because lots of growers in Ontario struggle with getting good red clover stands. And that was one of the things we found, is it seemed like the growers who were seeding at the high end, like Woody is, were getting a lot better stand success, stand establishment with their red clover. Just a little sidebar.
Did
this year was challenging.
Overwinter?
Crimson will occasionally overwinter, especially if I seed it a little later. If I seed it the 1st of August, it tends to try to throw a flower in October, and then it doesn't survive the winter. If I seed it a little later, I'll have it survive.
And then there was a clarifying question. Margaret was wondering if you could confirm what crop did the covers follow that allowed late summer planting?
So the beginning of the plot where I planted my cover crops into, is that the question?
I think so. I think it's about the covers followed wheat.
Yes.
Yeah, so it's winter wheat. So
Winter
that
wheat.
harvested in mid-July.
Mm-hmm, mm-hmm.
There you go, Margaret. All right. And Woody, can you describe your nitrogen management for corn? And did the study apply any nitrogen at planting?
No, there was no, somebody asked about a fertilizer on the strip till machine. I saw that in the chat. So I wanted to see what the manure would do. So there was no fall apply. Sorry, it's not correct. I did apply potash. So no fall applied phosphorus or anything, and no spring applied phosphorus or nitrogen with the planter. I turned it off for that. I wanted to see what the manure brought to the table.
And Woody, with your nitrogen management now, I know you got the research bug, and so you went out and did a replicated trial looking at side dress rates.
So I kind of did sort of similar to your trial. So manure was applied on the whole field, and I took 3 and Ralph rubbed off, randomized trial, randomized strips, 3 replications of 0, half rate, and full rate side dressed N. And I have the numbers here somewhere, but essentially I was growing with the hog manure, I was growing no yield difference between full and half rate side dressed N. So and I've done that twice now. So I'm quite comfortable to grow corn after manure on at least a half rate of N.
And since we ran some of the stats on that, technically no difference even with the 0 rate. But you don't like that statistical.
that statistical was about let's see, about $40 an acre. So that to me is statistically different. But that's as in bushels, but if you take the cost of side dressing and the cost of nitrogen out of the equation, it was likely closer to just $20. So.
And does all of the manure you use come from your pigs?
Yeah, that's the only manure I have access to.
Okay. All right, let's see here. So somebody was wondering about applying these research findings to any other fields, outside of agronomy. Can your research be used in a different field, like rebuilding forests after wildfires, maybe related to use of cover crops, nitrogen mix? How could this potentially be used in other situations or in other habitats or ecosystems, or any creative applications of what you found?
I'll let Cameron take that one on.
Okay, I'll take a first stab at it. I'll just say, okay, I'll apply it within agronomy, or like within kind of cropping systems, and then we can talk creative. But within cropping systems, I think this experiment is another case of how we need to think about cover crops as more than just covering the soil. We need to think about you're adding another crop to your rotation, and therefore you need to think about the same management principles as you do with crop rotation in general. So rye before corn, grass before grass. You want to avoid some of those challenges, and so Woody's talking about doing that with. Now he's using oats or an oat mix, something that's going to kill off with the winter, or if cereal rye is in the equation, then terminating it well in advance of that fall and corn crop so that you've got good time for that to die off and you're not going to run into any disease issues there. So I think that's kind of an application for other farms. You know, can you apply this experiment more broadly outside of agricultural situations? Like, I think just cover crops in general are the principle of having living roots in the ground for stabilizing soil, capturing leachable nutrients, is really valuable in ecosystem restoration. And so there's, I think there's a variety of degraded ecosystems that would do better to be managed by having living roots in the ground. And some of those species are, I know that there's a whole field of research on bioremediation, which is all about using plants in particular to take up toxic chemicals at like toxic waste sites and things like that. So it's transferable. I wouldn't say that there's some direct applications from this project, but there's transferable stuff.
That's a great response. Yeah. And then how was the research funded?
Yeah, so Ralph, my advisor, I believe he had, he was the Loblaw Sustainability Chair at the University of Guelph for a number of years. So I believe a lot of the funding came from that project, and then there was funding that I received as well from the Ontario Ministry of Agriculture, and and some other folks who supported us with some of our equipment and things like that.
The wind network, the weather station, was that volunteered?
Yeah, they volunteered a weather station so that we could get on-farm weather data. Hoskins Scientific helped us out a lot with the instruments that we were using, particularly for measuring soil water.
There's a bit of diesel fuel and farm equipment donated.
Yes. Yeah, the Vanarco has partially funded this as well.
Yeah.
I asked earlier, if you could redesign this research, how would you do it? But what about, like, out of all those additional questions that were generated through the process of going through this project, like, what one question is there anything that you really like wish you could dive into more, and like it's just like you're itching to like understand better?
It's led me down a different road, and that is a better understanding of crop and cover crop interactions. How positive and negative interactions happen between different cover crops, and whether it's a brassica ahead of corn, which is doesn't support mycorrhizal fungi, is that an issue? The rye corn thing, I found out there's a negative effect between a thick stand of cereal rye and sunflowers. So it's understanding how this all works together, and what are the negative interactions, what are positive interactions, and things like that. I have lots of questions.
Yeah, and I'll just say for myself, my master's thesis was, as I mentioned, on the effect of cover crops on water supply to corn, and I have a bunch of unanswered questions from that experiment. Like if I was crazy enough to do a PhD, then I have a whole nother experiment that I'd create to try and better understand. Well, I think this is what if I remember my thesis, this is what I talked about towards the end, is what I'd want to do is I would want to first play around with finding my ideal mix before I then go out to the field and try to then figure out whether or not it's working. So I think that's one thing, is like the second that you play with a mix, you're playing with an exponential number of variables. And so the fact that we got different establishment in our 2 years, there's like a foundational question in my mind of to get a good balance of species that are going to cover the soil, put good roots down in the ground that are going to open up biopores and things like that. This is kind of getting at Margaret's question: what factors contribute to your ideal mix? I think it's having a legume that's going to offset any nitrogen immobilization issues that you might have with a grass. It's going to have a grass which provides good residue cover over the soil, kind of prevent evaporative water loss, and it's going to have a good root crop, like a sunflower that's got a good tap root on it, or a tillage radish, or something that's going to create good biopores down in the soil that the fallen corn crop or fallen crop can access. Those are kind of the three things. So a legume, a grass, and a root crop. And then you got to figure out what the ideal seeding rate is for each of those, so that they don't outcompete each other. So then it's just, I could go on. Yeah, there you go. Margaret's got it too. Then you got to figure out the seeding rate. It's like it's never ending.
It's a bit of an art.
Yeah.
Woody, you shared how this experience has helped you understand research and researchers. Cameron, how has this experience helped you in your new role?
I think it's related to what I said earlier about recognizing that everyone is an expert in their own right. I'm working on a project with potato producers right now, and I'm not a potato expert, and that's not a bad thing. Like the fact that I am not an expert in potatoes means that I am walking into the room with those growers, and I need to rely on their expertise to understand potato production, and they can rely on my expertise in understanding soil health management. And that's where great synergy and collaboration can occur, is when you realize that both of you bring something valuable to the table, and you need to listen to each other. You need to be curious to understand how each other see the situation, and yeah, good opportunities can come out of that.
Great. There was a question that I missed earlier. Are you terminating the clover crop, or is it growing throughout the season?
That's referring to my clover strip till type. Red clover, I've learned the hard way. You terminate that before or at planting. It's a very aggressive, slow to die cover crop in the spring, so it will almost smother out a corn plant if I'm not careful. So it's terminated at the latest at planting.
Great.
Or at least set on its way to dying.
All right, and then I guess we've got one more in here that wasn't a question. It was kind of just like a conversation starter. So somebody said, though yield is an obvious tool for measuring between research plots, shouldn't we be taking a host of other variables into consideration when assessing the value of cover crops? We have significant groundwater nitrate issues in my neck of the woods, and I have to think that the integration of cover crops provides environmental benefits that are difficult to monetize. And this is, I think, Cameron, something you've been getting at this whole time too.
Well,
100%.
we're also nitrogen is a little bit of an issue, but with Lake Erie and phosphorus runoff is a serious concern here. It's a little philosophical almost, isn't it? I guess it depends on society's value for a farmer to do that. And like I said in my beginning, that I can do all kinds of cool things for my soil, but I still have to make a living farming. So I am willing to spend personally, because I think I should, a little bit of extra or maybe a slight yield hit to do what I do. But I can't ask anybody else to do that when it's their livelihood.
And if I can jump in on that one too, I'll say that 100%, like the person who made the comment is absolutely right. We do need to look at other variables. But the variables that you decide to look at are going to depend on the goal that you're trying to achieve. And so the person making the comment, obviously one of their goals is to reduce nutrient loss to water bodies. And so then that is going to, it doesn't make sense in that case to look at yield. Whereas in the experiment that we were working on with Woody, we weren't expressly setting out to use cover crops to reduce nitrate leaching, for example. We were setting out to use cover crops to take up nitrogen from manure and release it to the following corn crop, and to see how effectively they would do that. And so we used a number of indicators there, looking at soil nitrate levels and nitrogen content in the corn plant, and then yield, of course. So just to say that, yes, we should look at other variables, but what those variables are is going to depend on the question that you're asking. And yeah, I'll stop there.
We didn't get into it, Cameron, but we also did an economic analysis of the different treatments as well.
Yeah.
And I don't.
What are your takeaways from that?
I have to go back to look at the numbers. It's been a couple of years now. But.
The interesting thing, especially from a nutrient management perspective, is that the most profitable nutrient management regime was manure in the fall, manure in the fall with the cover crop and a full drain of side dress nitrogen, which from a nutrient management perspective and water loss or nutrient loss to water bodies, it's not necessarily the system that minimizes that loss potential, but this kind of just shows you how I think the complexity of what Woody's talking about, where environmental concerns, we need to find the opportunities where environmental concerns are farmer concerns, because they're win-win situations for farmers.
I think that's an excellent note to end things out on. Thank you both so much for taking the time to put this Farminar presentation together for the audience, and thank you everybody that attended tonight. I hope that you learned something interesting, and I will send an email out tomorrow thanking everybody and also nudging you on that evaluation one more time if you don't do it tonight. Woody, Cameron, thank you very much. Really appreciate all of your time and sharing your experience with us.
My pleasure. Thanks, Woody.
Yep.
Good night, everyone.
Night.
Bye.